Hey guys, all right. So that first day that we talked about verifying using these trig identities, we talked about rewriting everything in terms of sine and cosine first, and that'd be a good strategy to use to start kind of with easier problems to get us there. Now, what we're going to talk about today is we're still going to kind of keep it simple, but today what we're really going to focus on is we're going to focus on these Pythagorean identities right here in the middle, and we're going to think about how we could possibly use these, rearrange these to end up verifying the left side of an equation equals the right side of the equation. The one important thing that you guys have to know when using these Pythagorean identities is that your trig functions are squared. So if you look at this first one, you can see like sine squared u plus cosine squared u is equal to 1. Or the next one, 1 plus tangent squared u is equal to secant squared u. So make sure that when you're using these, your trig functions have to be squared in order for you guys to rewrite these. All right. All right. So let's try to see if I can do that same thing and move this over to one half of the screen and move this over to the other half. All right, let me see if I can get that back up. Okay, cool. All right, so let me erase some things here before we get started. Okay. All right, so if we look at this first problem on our notes over here, you guys are going to see this first problem says that we have sine squared x plus cosine squared x all over cosecant x is equal to sine of x. So remember, we're just verifying like we did the other day. So you guys aren't changing the right side at all. You're keeping that the same, but we do want to change the left side. So in this case, in terms of rewriting everything in terms of sine and cosine, we do want to do that. But in this case, actually on the bottom, keep that cosecant exactly like you see it. So the reason why we're doing that, because if we see, in this case, up top, that's sine squared plus cosine squared x, and we know that one of our Pythagorean theorems has sine squared plus cosine squared, what we can do is we can take the top of that numerator and we can just convert that into a 1, because that's what our Pythagorean theorem says. Now that 1 is still going to be all over cosecant of x. All right, so using that Pythagorean identity, you can just take that entire numerator, and since sine plus cosine is equal to 1, you can just substitute that 1 in for it. Now, once you guys have 1 over cosecant and you're trying to get sine squared x on that right side, well, if we look at what cosecant is, back to what we talked about that first day, well, cosecant is the same exact thing as 1 over sine, or I should say, more importantly, if we look at sine, which is right above it, sine is actually the same thing as 1 over cosecant. So once you guys have 1 over cosecant, well, that's really the exact same thing as having just sine of x. And sine of x is the same exact thing as sine of x, so we verified it. All right. Now, before we move on, there are ways that you guys can like rearrange this Pythagorean theorem to kind of help you out a little bit more. And we'll see that on the next problem. All right. All right, so if we go to our next problem, problem number 2, you guys see that you have 1 minus cosecant squared, 1 minus cosine squared x times sine squared x has to equal sine to the 4th x. All right, so what we can do with these Pythagorean identities is kind of rearrange them. So, for example, if you guys look at this first Pythagorean identity that we're starting with, the sine squared plus cosine squared is equal to 1. So I'm going to write that up top. So this is saying that we have sine squared x plus cosine squared x is equal to 1. All right, so what we can do, what I mean by like rearranging things, you can move things to like either place. Like for example, if I was say I wanted to take this Pythagorean identity as an equation and I want to solve it for just sine, what I can do is I can actually subtract a cosine squared x on both sides, just like solving like a normal equation. Sorry, I know that's kind of jammed in there. All right, but your cosine squares will cancel out. So what we end up getting is we end up getting that sine squared x is now equal to 1 minus cosine squared x. All right, so that's really important that you guys know that you can rearrange this Pythagorean theorem to help you out. So like if we're looking at like problem number 2 over here, if we look at this now, we have 1 minus cosine squared x right away off that parenthesis. Well, by rearranging our Pythagorean theorem just like we did over on this side, I know that 1 minus cosine squared x is the same exact thing as having sine squared x. So I can take this whole entire thing here and I can just replace this with a sine squared x using that Pythagorean identity. Now, after that sine squared x, we still have sine squared x after it, still being multiplied, and we know we have to get it equal to sine to the fourth of x. Once we have that sine x squared, sine squared x, we're multiplying them together. They have the same bases, just like we talked about in that first day. We know that we can actually go through and then add their exponents so that we ended up getting sine to the fourth of x, and that's exactly what we were trying to find. All right, so you guys can always rearrange these things to try to help you verify an equation. All right, one more example that I want to show you guys, and it's really similar. It's just kind of rearranging that Pythagorean theorem in a little bit of a different way. All right. So if you guys look at this third problem, try to find it. All right, so this third problem, we have 1 minus sine squared x over sine squared x is equal to cotangent squared x. All right, so same thing. I know right now it might not look like we have anything in this identity sheet over here that has a 1 minus sine squared x, but just like we talked about, we can use that Pythagorean identity to help us kind of rearrange some things. So if I write that again up top, that original identity that we have. So on last problem, we went through and we tried to solve for sine and get sine by itself. So this time, let's go through and like do the same thing, but get cosine by itself and see what happens. So I can actually subtract the sine squared x on both sides. And when I do that, now all of a sudden I'm just going to be left with that cosine squared x. And now that cosine squared x is now equal to 1 minus sine squared x. All right, so you can do the exact same thing with cosine and learn how to rewrite using that cosine squared. So cosine squared x is really equal to 1 minus sine squared x, just rearranging that Pythagorean identity. So if you guys take a look at 3 and you look at that numerator and you see that you have a 1 minus sine squared x, right away you guys can replace that with a cosine squared x. Now that's still going to be over sine squared x, which is on the bottom. All right, but remember, your guys' main goal is to eventually get cotangent squared x. All right, so now that we have this, we have cosine squared over sine squared. If you guys, and I'll change this up to green just so it kind of sticks out. But if you're trying to get cotangent and you look to see how you can rewrite cotangent using those quotient properties we talked about in that first day, well, we know cotangent is rewritten as cosine over sine. We talked about this the first day too. Just keep your exponents, keep them consistent. So if cotangent's cosine over sine, but now we have cosine squared over sine squared, well, I can take cosine squared over sine squared and just rewrite that as cotangent, but the cotangent has to be squared as well. But that's exactly what we're trying to verify. All right. So again, big thing, guys, today's lesson, make sure you know those Pythagorean identities, especially using sine squared plus cosine squared is equal to 1. You can rearrange that equation to make that either sine squared equals or cosine squared equals to help you verify some of these equations. All right. So on that same worksheet, I'm going to have you guys do problems numbers 7 through 10. If you guys have any questions, let me know, email me, or I'll have that Google Meet session to so you guys can answer any questions you or ask any questions you have. All right. I'll see you guys later.